How to read Homer in 20 minutes. Download the Iliad and the Odyssey from your favorite repository. I downloaded these items from Project Gutenberg. They were originally written/translated by Samuel Butler. Print the resulting files. Combined, the Iliad and the Odyssey are about 400 pages long. For extra credit, bind them into a codex. Use the traditional process to read the result. I'll wait. In the meantime, I'll remove the extraneous information like the headers, the footers, and the introductions from each file and divide the result into individual chapters. And then I'll use the resulting files as input to any number of different software applications. In this case, I'll use a system called the Distant Reader Toolbox. The toolbox takes the input, does a whole lot of feature extraction against it, and saves the result as a delimited files and a relational database. The combination of these things is a data set, but I call them study carols. Put another way, the toolbox takes a set of unstructured data as input, applies both text mining and natural language processing against it, and outputs a set of structured data amenable to computation. On my computer's desktop, there's a folder named Homer, and it includes a set of plain text files. Each is a book from the Iliad or the Odyssey. I can build a data set from these text files, and I'll call this data set Homer. The reader copies the files to a separate directory, does all sorts of feature extraction against it, and saves the result as a set of delimited files and a relational database. The reader can take as many files as you give it and of any type, but it works best with a few dozen files and plain text files. PDF files are fine too. Depending on the number of files given and the sizes of the files, the build process can take between 1 minute and a few hours to complete. The result is a data set, something amenable to computation. Moreover, the dataset is computer, platform, and network independent. These datasets will last for forever and can be given to other people for their use too. Once a study carol has been created, it can be modeled in quite a number of different ways, and each model sheds a different light on the content. For example, we can learn about a carol's extent, its size and scope. The toolbox's info command outputs something akin to a tiny little catalog card, where you can see how many items are in the catalog, how big it is, and what its readability scores are. We can create a rudimentary bibliography from the carol, and it includes computed summaries, a list of statistically significant keywords, and absolute pointers to the cache where the original items can be found. Like any bibliography, it can be used as a sort of index. Query the index for items of interest, peruse the associated document. The bib command outputs little bibliography, complete with titles, abstracts, computed keywords, and locations to where the original documents are located on the local file system. I can use the keywords, select keywords, and then grep for them and find other items that are like the given item. Once I identify an item of interest, I can select that text and open it up in my terminal. I can then use my pager's terminal command to find that particular word and peruse the entire document. Counting and tabulating the unigrams in a document can be quite informative, and visually the result tells a story. Since words are known by company they keep, the same thing can be done for bigrams and tells a similar story. By default, the reader will list all the unigrams in a carol. But you can also count and tabulate these unigrams and put them through your pager. The same thing can be done with any sized NGRAM. You can use your pager to filter the results. Alternatively, you can use the reader to filter the result. The reader accepts any kind of regular expression. It is also possible to visualize the result as a word cloud. The results of NGRAM analysis can be used as input to concordancing, and thus begin to answer the question, how are these used and in what context with other words? Concordances are also useful to bring to light well-known combinations of words. My favorite are nouns and the verb to be. Concordances are a particularly helpful modeling technique. By default, the reader will search for love. But it's also possible to put in other words of interest, such as Hector, and the whole thing can be put through your pager. Once you're in your pager, you can search for a more specific word or a more specific phrase. Who is Hector? Who was Hector? You could also put this sort of query directly into the RDR to only get those items. You can also use your terminal to make the whole thing look prettier. I also find it interesting to take the words output by the concordance and put them into Wordle. What words are used in combination of these words? Another way of identifying interesting words is to compute them. TF-IDF is a well-known technique, but the toolbox uses an algorithm called YAKE. Again, the result can be visualized as a word cloud. The toolbox computed statistically significant keywords. It's possible to count and tabulate these words, put them to the pager to see which ones are the most frequent, or visualize them as a word cloud. Clustering, as opposed to classification, is a popular way to characterize a corpus. Through the use of dimension reduction technique called PCA, our Carol seems to fall into two distinct groups, but we don't exactly know what those groups are. Still, such analysis points to what might be a good topic model. Using PCA, it's possible to reduce the number of features in a document, and here we can see that our document falls into two very gross categories. We can reduce the document into only 3 characteristics, visualize it as a cube, and we see again that Homer's Iliad and Odyssey fall into 2 distinct groups. Topic modeling, usually in the form of LDA, is another popular clustering technique. I usually start out small and work up. I also use the number of items in the corpus as a guide to the maximum number of topics. Using the result of PCA, let's topic model Homer using only 2 topics. The most heavily weighted words in each topic can be used as labels, and we might say Homer is about Sun and Ulysses. This can be visualized. Half of the corpus is about one topic and 1/2 is about the other. We can also visualize this as a timeline, illustrating the ebb and flows of ideas over time. Notice how the first half of Homer is about one thing and the second half is about another. By default, the toolbox topics on 8 topics. And more finely grained topics present themselves. Notice the ebb and flow ideas over Homer. For example, the brown line represents sea when Ulysses is sailing home. Reducing the features of a corpus down to a relational database, full text indexing the result, and providing an expressive query language on top is another way to model narrative texts. Using this technique, all sorts of different views can be gathered. We can add and supply a very specific search against the full text index, identify the document that it matches. There's only one. It's all about Penelope, suitors, and Ulysses. We can then select a particular item and read the item in its full text nature. Language follows patterns. If it didn't, then we would not be able to understand one another. So far, all the modeling techniques can be applied to any language, sans grammar. When modeling the text so each word is associated with a part of speech, new questions can be asked and answered, such as, what is mentioned in this text, what do those things do, and how are they described? By default, the reader will simply output all the parts of speech. It's possible to count and tabulate these parts of speech. There are a lot of nouns. What nouns exist? And how frequently? There are sons, houses, and gods. How are these things described? Angry, full, much, young, high. It's also possible to output the lemmas of words And this is great for verbs. What do things do? Nouns are a special case. They can be modeled into named entities: people, places, organizations, states, times, money amounts, etc. Analysis of these things addresses another set of questions, such as what types of things are in this corpus and how are they related to one another. By default, the reader will output all the entities. It's possible to count and tabulate these entities. Apparently there are a lot of people. Let's look at who the people are. Ulysses is a big person. Let's look at when things happen, dates and times. Applying grammars to the text highlights additional patterns. The toolbox supports a number of grammars, and extracting sentences with a given grammar. It is then possible to compare and contrast all sorts of things. By default, the reader will output all the subject, verb, object fragments it can find. It is easier to find patterns if the output is sorted. The results can be filtered. Tell me about Hector. What does Hector do? What does the generic he have? What does she have? What do I have? Again, words are known by the company that they keep. And exploiting collocations is one way to see what words are used in conjunction with other words. By default, the toolbox will create a set of collocations, transform the result into a network graph, and illustrate the results. But it is more informative to save the graph as a file and visualize it with something like Gephi. It is useful to measure different aspects of the graph, for example, the betweenness of the nodes, or the clusters. Think topics. Laying out the graph in a force-directed manner illustrates how the clusters overlap. Turning on the words adds context. For example, how is the word sun used? Or Minerva. Laying out the graph as a spiral illustrates the size and scope of the clusters. The Distant Reader Toolbox consumes unstructured data, applies text mining and natural language processing against it, saves the result as a data set. These data sets are called study carols and lend themselves to computing and answering all sorts of different research questions. P.S. Here's the totality of Charles Dickens' works. Maybe I'll read it too.